Okay, so hopefully you've thought about this question a little bit, and knowing that the function is a parabola, that the domain is of course going to be an x element of the real numbers. Now, since we're talking about the domain and range of the inverse, knowing the domain of the function helps us a little bit, because what that can tell us is that if the domain of the original is x an element of the real numbers, that means the range of the inverse will be y as an element of the real numbers. Okay, which is a very good start. The only problem is we don't know the domain of the inverse, so we'll need to know the range of the original. Now, again, if you really wanted to, you could actually find the inverse. You could go through, put the equation in vertex form, and find the inverse from there, and then try and find the domain straight from there. However, that could be a bit more complicated. And of course, the equation that you're going to get is going to be not necessarily the easiest to get to get the domain from. So the easiest thing to do instead of directly find the domain of the inverse is actually start by finding the range of the original. So if you want to find the range of the original, you need to know where the vertex is. So using some method to be able to find the vertex of f of x. Now, if you've already done that, I'll give you the opportunity to check your answer down here. Okay, if everything's good, then you can move on and try the next example. Otherwise, what I'd like you to try and do is put this into vertex form and see if you can get the correct domain. Okay, so just to do a different approach to finding the vertex, I decided to use partial factoring for this one. So I common factored the x out of the first two terms, left me a 3x minus 7. So I have x times 3x minus 7 plus 9. This would tell me I have two symmetric points, one at the coordinate 0, 9, the other the coordinate 7 over 3, 9. I can use these two x values here to find the axis symmetry. So halfway between 0 and 7 over 3, I get 7 over 6. I then sub that value back in the original equation for x to solve for the optimal value, which winds up being 59 over 12. So it tells me my vertex is going to be at 7 over 6 for x and 59 over 12 for y. So that helps me find the vertex, because now I know that, since I know where my optimal value is, I know the parabola opens up because my a value is positive, that my that my range is going to be any y value larger than or equal to 59 over 12. So it means here, if this is going to be my range, it's going to be my range of my original function. The domain of my inverse will be x is anything larger than or equal to 59 over 12. Okay, so again, to get the domain and range helps to have vertex form. Now once that's all done, it's just a matter of interchanging them to get the domain and range of your inverse. Okay, one last example here. It says determine the vertex by completing the square. Now I will say in practice, I actually don't care what method you use to determine the vertex or to put into vertex form. So whether you use completing the square, partial factoring, or find the axis symmetry using x equals negative b over 2a, then substituting that into the equation and get the vertex is fine by me. I'll never specify that you have to use one way or the other on an evaluation. So as long as you can get to vertex form in some way from standard form, that's perfectly fine. Now this particular one says use completing the square, so we're going to do so. So remember, to complete the square, what you need to do is first factor out the a value out of the first two terms right here. So you're going to give me y equals 2 over 3. You're going to get x squared. I'll deal with this part here in a second. This minus 4 sticks around. So remember, I'm taking negative 11 over 5, and I'm factoring out 2 over 3, so I have to divide negative 11 over 5 by 2 over 3 to figure out what's going to be left over. So that's going to be equal to negative 11 over 5 times 3 halves, which will give me, looks like, negative 33 over 10. Nice, lovely number. So I get x squared minus 33 over 10x. Okay, now what I'd like you to see here, as ugly as these numbers are, completing the square actually isn't that bad to do. Because as ugly as numbers are going to get, the array will actually tell you how everything's going to factor. So what I recommend you do now is set up the array. And we're going to use this to try and complete the square. So remember, I'm going to have x squared up here. So remember, if I have negative 33 over 10x, I have to divide that in 2 evenly over these two sections of the array to get a perfect square. So if I have negative 33 over 10 and I divide by 2, that's going to be equal to negative 33 over 10 times a half, which is negative 33 over 20. So I'm going to have negative 33 over 20x in here, and negative 33 over 20x here. So that means on the outside of my array, get x minus 33 over 20 and x minus 33 over 20. Now, as ugly as this gets, again, just follow the array and everything's going to work out nicely. So that means in the bottom right down here, I have negative 3 over 20 times negative 33 over 20 gives you 1089 over 400, which again looks very, very ugly, but again, just follow the array, everything will work out. So what this tells me now is if I'm trying to complete the square, I have x squared minus 33 over 10x. So I need to add and subtract 1089 over 400. So add that in to create my perfect square. Just to make sure I don't do anything illegal, I have to balance this out by subtracting it as well. Okay, and now you have to remember here that to create my perfect square, this is what I need. This is what's in my array that creates a perfect square. This other part right here is negative 1089 over 400. I don't actually want in there. It's not part of my perfect square, so I'm going to remove it from the bracket. But remember that everything in this bracket is multiplied by 2/3. So I'm going to take this 1089 over 400 outside the bracket. It needs to get multiplied by that 2/3. So just show you how that works. Again, it's very similar to different examples you've done completing the square, just the numbers are a little bit uglier this time. So I'm going to get my 2/3. Inside here I now have x squared minus 33 over 10x plus 1089 over 400. And again, that's what I want in there. That's exactly what's inside my array over here to the right. That's what's going to give me my perfect square. So this minus 1089 over 400 comes outside the bracket. Then we have to subtract 4, and then, sorry, before I subtract 4, of course, I have to multiply by the 2/3 that's out in front here. Okay, and then I can subtract the 4 that was out there originally. Okay, so we're actually almost done, as ugly as it looks. And remember here, normally I would never ask you to factor something like this because the numbers are too ugly, but again, since you have the array already drawn out here, you know right off the bat this factors into x minus 33 over 20, all squared. Okay, it's just a matter of simplifying this part out here. So you have negative 1089 over 400 times 2/3, then you subtract 4. So if you do some math here, I'm going to let you try that on your own, you should wind up with negative 1163 over 200. Okay, so that gives me my equation in vertex form. So then from there I should be able to get my vertex relatively quickly. I can just look at the equation, remove my axis symmetry and my optimal value, and state my vertex there. Okay, so that's it. There's some homework there from the textbook. There's also a worksheet as well. That's really just a lot of practice of completing the square. But again, you can take that worksheet and use whatever method you like to get from standard form to vertex form. As long as you get the same answer in the end, the method that you take to get there doesn't actually matter. Okay, so that's it, and then you can move on from here.